6-2 kites and trapezoids. So we're going to start with kites and then move to trapezoids. Yeah, I would still encourage you to be going back over your notes while you're doing homework and highlighting stuff. If you need highlighters, I do have some up here that you can borrow while you're in class. So, okay, so a kite. A kite has two pairs of congruent adjacent sides. So if you look at your picture, congruent means they're the same. Adjacent means they touch. Where does AB and BC touch? At where?
Middle.
At B. Okay? They share something. That makes them adjacent. AD and DC share what? D. So that makes them adjacent. So if it is a kite, both of these sets of sides are congruent to each other. The diagonals, a diagonal and a polygon is anything that goes from one vertex to another. The diagonals are perpendicular. What does that mean? They intersect at a 90-degree angle. Yeah. So we have one square, but all four angles are right angles. And I'm going to rephrase how this is written a little bit. It says one diagonal, and it is bisects, but I'm going to say the short diagonal is bisected by the long diagonal. Because obviously the short isn't bisecting the long, right? So what does it mean to bisect? Cut in what? Half. So that tells me that's what these three lines are telling me, that these two pieces are congruent, correct? Right. So those are some characteristics about a kite that we will be able to use to solve for different parts of the kite. Am I good? Yes. So what is the measure of AXB? So didn't turn on my pen. AXB. So that means right here. What is that? 90 degrees. The next one tells me AX is 3.8, and it asks me what AC is.
4.6.
I need to times it by 2.
7.6.
Why do I need to times it by 2?
Because it's half of one side.
Because it's double the length. So 7.6, and if there's meters, inches, whatever, I'd put it there, right? Could I said 3.8 plus 3.8?
Yeah.
Yes. Either way, it's going to be 7.6. Am I good?
Yeah.
1 second.
Yep. Okay, so we need to find the measures of 1, 2, and 3. So, angle 1 is a what?
90.
90-degree angle, because they are perpendicular, right? Well, how are we going to find angle 2?
We know that angle, is it like the one by P?
We know this one's 35, right?
The one up from that is 90.
90 degrees because it's
So you add those and subtract from 180.
So I could take 180 minus 125, right? Which would be 55.
Yeah.
Okay, I would have done 90 minus 35. I still got 55. How can I take 90 minus 35?
Because 90 plus 90 equals 180.
Yeah, because I know this angle's 90, yes?
Yeah.
So the other two have to add to 90, right? So does it matter either way I do that? No. Okay, so angle 3.
Same thing.
Yeah, it's just.
It's not 55.
35.
No.
It's
but you-
35. Why?
Because they're congruent.
Because these are congruent triangles, correct?
Yes.
So angle 3 is congruent to angle what? QPT?
Yeah.
And so it equals 35 degrees. Now, do I need to say that angle 3 is congruent to angle QPT?
Yes. You need to
Yes,
show your work.
because you need to show your work. Is there any other way to name angle QPT? Right here. The answer is no. I can't say angle P because it could be in 1, 2, 3 different triangles, correct?
Yeah.
Okay. I can't name it QPS because that's the whole thing. So the reason I'm doing this is to make you guys remember and use the proper way to name angles. Questions? Okay, the next one I want you to try on your own. I want angle 1 and angle 2. Oh, we're going to name the intersection point P. How about that? Because we might need that, huh? Phoenix, what's the measure of angle 1?
I have no clue.
Okay. Do you see that there's a triangle right here?
Yes.
Okay. What is the angle right here?
90.
90. And this is 35, so how can I find angle 1?
Subtract 32.
Or
from
32.
90.
What?
Subtract 32 from 90.
Yeah.
It's 58.
So 90 minus 32. So it's 58. Do you guys have 58?
Yes.
Okay. See, you did have a clue. Sarah, what's the measure of angle 2?
I haven't gotten it yet. I'm a slow worker.
Okay. Do you want to work it out loud? Or no? Okay. Jenna?
32.
That's what I put.
So you're going to say this angle is 32. Why?
It's the same thing.
As what?
He's 90.
It's congruent.
It's congruent to what angle?
It's congruent to X and Y. YWZ.
It's,
No.
how about P?
WX.
No. PX.
W.
PXY.
No, PX.
W.
Oh.
Okay, well, I had the same ones in an opposite order.
Okay, why does P have to go first?
It's
Alphabetical order. But X has to be in the middle, right?
Yes.
So the only thing you can really put in alphabetical order are the first and the end?
Well, I had it right.
Yeah. Just working on getting it more right. Okay. Questions on those, guys?
No.
Okay. So those are kites. We don't get to go fly kites. That'd be fun. It's kind of windy today. Okay. Now, what you have 3 different trapezoids, and these are all called isosceles trapezoids. So isosceles triangles have 2 sides that are the same, yes?
Yeah.
So guess what isosceles trapezoids have?
Two sides are the same.
Two sides are the same. And they specifically are what they call the legs, these parts. Okay? So, there's things that we need to know about them. We know that EF, right here, is congruent to CF because BE is the altitude, just the height of it. Just a second. Okay, so the other thing is we call the top and the bottom, we call them bases. Okay, so we usually say, I always say the one on the bottom is base 1 and the one on the top is base 2, but could I flip it around and say base 1 and base 2? Yes. Okay, the other thing is the bases are what to each other? What do those little arrows say? They're parallel. Okay, so since they're parallel, we have things like this, maybe. So I have like alternate interior angles, right? And I have same side interior angles, all that kind of fun stuff. So I have all those things that can help me find stuff. With that altitude, I've cut it into two congruent triangles. And what's in the middle?
A square.
A rectangle. So if I asked you that for the area of that, there's a formula for the area of a trapezoid. There is, and I'll teach it to you. But could I just make two congruent triangles and find the area? And then find the area of the rectangle and add it up? Yeah. So there's lots of fun stuff about these that we can use. So going down to the middle one, I think that's your picture on your right. Is it? Okay. So it tells me that AC is congruent to, so here's AC, guess what? DB. So this is only if it is an isosceles trapezoid, okay? So if it's an isosceles trapezoid, those two diagonals are congruent. That might be helpful, correct? Okay. Now, if it is an isosceles trapezoid, BAD, so BAD down here, is congruent to ADC. So the base angles are congruent. And ABC, so ABC up here is congruent to BCD. Now a trapezoid is a quadrilateral, meaning it has how many sides? 4. And so what do all those angles add up to be? What do all 4 of these add up to be? 360, yes? Okay. Now, this is parallel to this, correct? So what should the sum of these two angles be? 180, because they would be same side interior, wouldn't they? So is that all information that's probably going to be helpful?
Yeah. Yes.
Okay. Am I good? Okay, so it says given the isosceles trapezoid PQRS, you just name them by the vertices in alphabetical order. What is the measure of angle P, Q, and S? Anybody want to? Kale, you got an idea of any of them?
Q 135 maybe.
Well, Q and R. So angle Q is congruent to angle what? R, which is equal to what? 135.
What did I do?
Okay. Okay, all of those people who are shaking their legs, can you stop? Because it's shaking the entire room. Thank you. There's more than one. Okay, so these two angles are 135. Yes? And only because it is a what kind of trapezoid? Isosceles. So then we need P and S. What do we know about P and S?
They're congruent.
They are congruent.
You can add
So
them.
angle P is congruent to angle S. But how are we going to figure out what they equal?
360.
You could take 180 minus 135 and you get the
Because these are parallel,
number 45.
in this, what do these two angles equal?
180.
180. So I can take 180 minus 135, which equals 45. Now, Kale said something different. Kale, what'd you say?
You said 360.
Okay, so if you add all of them up, they equal 360, yes?
Yeah.
And I'd have to subtract what?
135 plus 135.
So that'd be 170
270.
or 270.
And then you have to divide by 2.
And so that would give me 90. And then I would have to divide it by 2, which would give me
45.
45. So is there an efficient way and a not so efficient way?
Yes.
Yes. But are they both right answers?
Yes.
Okay. So it says given that ST is parallel to RU. So ST is parallel to RU. Okay, so that tells me that it's an isosceles trapezoid, yes? Also because it has these little tick marks there, right? It wants to know TUR. So in here. So how are we going to find TUR?
180 minus 47 because it gives you the angle.
So if I take 180 minus 47, that's giving me SRU.
Yes,
No.
but then they're congruent, so they equal the same.
So TUR is congruent to SRU. And we know that SRU and 47 are a linear pair, yes?
Yes.
So that is going to be equal to 180 minus 47, 133. So we're back to those parallel lines and transversals, huh? Questions?
No.
Okay. Now, has anybody gone down the road and seen one of these big electrical, they hold high voltage lines? You seen those before?
One that looks like people.
Mm-hmm.
Absolutely not.
Okay, what do you see on the top? There's a trapezoid here, yes?
Yeah.
What do you see here? A trapezoid. There are triangles in there too, yes? And what do you see down here? Another trapezoid. Now, my legs are getting less slanted, yes, but is it still a trapezoid?
Yes.
Yeah. Okay, so we have lots of information. So let's read what it says. It says, all horizontal beams of a high voltage transmission tower are parallel to the ground. So that means this is parallel to this, which is parallel to this, which is parallel to the ground. Could that be helpful? Yeah. The top section is an isosceles triangle. The center section is an isosceles triangle. A trapezoid, thank you. And the reason for that is because my legs on the top are 10 and 10. My legs in the middle are what? 14 and 14. Well, I would assume this down here would also be what?
14 and 14.
Well, not 14 and 14, but they would be the same, right?
Yes.
Okay. So, angle 1 is 138 degrees. What is the measure of angle 2?
I can't tell which one angle 2 is.
Angle 2 is down here.
Yeah, but they just. Oh, okay.
And angle 1 is up here.
That's 138.
So how are we going to figure that out?
I don't know.
180 times 138.
Well, I know 1 is
Well, you know-
congruent to here, yes?
Yes,
Yeah,
but
yeah,
yes.
so then you can find the other two by 360 minus.
No, I was gonna say that there is a 90-degree angle.
No. What do we know about these two angles?
Parallel.
This angle and this angle.
What?
What do we know? These are two parallel lines with a transversal. What do we know about this angle and This angle.
They're what's same side interior.
They're same side interior, so they are supplementary.
Yes.
What's supplementary?
They equal 180.
They equal 180.
So you take 180 minus 1.
So angle 2 would equal 180 minus 138. I was looking for it on the picture. Which would be 42.
And then the other side.
And then the other side would be 42, right?
Yeah.
Okay. Give you a lot of space for a little bit amount of work. So we're going to go down to the second section, the cross beams. So it says one cross support is 4C plus 3. And the other is 6C minus 5. So what's the length of the cross supports? What do we know about
4C plus 3.
what do we know about these two?
They're equal to each other.
They're congruent, yes.
So you can set 4C plus 3.
So 4C plus 3 equals,
6C minus 5.
so find the length. Find the length.
Okay. I don't know. No. I like this stuff.
60.
So I'm assuming you subtracted 4C.
You went to put 5.
I got 2C.
You have 6.
minus-
Oh, I have 5. It should be 5,
They
right?
should both equal 19.
Mhm.
Okay. And add 5.
Yep.
So then I get 8 equals 2C.
Divide.
So C equals 4. But that's what it's asking?
No, you have to plug 4 in.
Okay. You have to plug 4 in. So 4 times 4 is 16 plus 3 is
19.
19. So a check would be to both, right? 4 times 6 is 24. Minus 5 is 19. So they are 19 feet. Have we been doing like this, stuff like this, like all semester?
Yes.
Yes. So do the next problem on your own. Am I good to switch it yet?
I guess.
Given the isosceles triangle MNOP, where the given expression represents the measures of the diagonal, what is the value of A? Sarah. Did you get 14?
Yes.
Did anyone not get 14? Okay. Am I good? No, we're not. Sarah, are you good? Okay. Amber? Okay. So, last rule, last thing that will help you, but there's some things that have to happen. So if, first of all, this is a trapezoid, yes? Is it an isosceles trapezoid?
No.
You don't know. Because the isosceles trapezoid has to have both legs, the diagonals equal. Does this tell you they're equal? No. They could be, but do they have to be?
No.
No. But the top has to be parallel to the bottom.
It is.
Okay? The left two pieces have to be equal, and the right. So that means that XY bisects those two sides. Yes? But those two sides don't have to be the same length. They just have to be bisected by XY. So, let me erase this mess that I've drawn on here. It says, if this picture is correct, then XY is parallel to BC, and XY is parallel to AD. So the midsection, the mid-segment is what they call it, is parallel to both the top base and the bottom base. Okay? So if all this works and is really good, then we can use this. And it says the length of the mid-segment, that XY, is equal to, guys, quit shaking. You're shaking the whole room. Dakota, you too. Is 1/2 the sum of the two bases. They didn't put the lines above. You guys put the lines above them. I hate when they don't put the lines above them. Okay? So the middle is 1/2 of the two bases added together. But only if everything up here works. Got it?
Guess not.
Okay, we good?
Yes.
So now let's use it. So it says, given the trapezoid JKLM, what is KL? So KL is this top base, correct?
Yeah.
We're looking for this right here.
Bottom's half of it.
Well, we have some things working for us. We know that these two sides are congruent.
Yes.
Yes, or segments. We know that these two segments are congruent.
Yep.
Yep. So that means the top and the bottom have to be parallel. So that means I can use XY equals 1/2 the top base plus the bottom base. Okay. So what information? I'm looking for KL. So I'm looking for this top, aren't I? So we'll have other pieces, right? Do we know what XY is? 25? So it's 25 equals 1/2. We don't know KL, do we?
No.
Plus, do we know JM?
4/5.
Okay, so JM, I don't like how this is written. We need to put something there. This looks like, to me, 4/5 X times Y, doesn't it to you?
Yes.
But it's not. It's actually what should be above that, that line. So it's 4/5 of XY. So 4/5 of this segment XY. So do we know what XY is?
Yes.
What is it?
25.
So I have 1/2 equal, 25 equals 1/2 of KL plus 4/5 of 25. Okay, well, we probably should get rid of this 1/2, and I don't want to distribute it because we got some things going. Can I just multiply both sides by 2?
Yeah.
Okay. So on the right, the 1/2 and the 2 reduce. So 2 times 25 is 50 equals KL plus, well, I think we should be able to simplify 4/5 times 25 because that's 25 over 1, correct? Does 5 go into 25?
Yes.
5, and 4 times 5 is 20. So that looks a lot better already, doesn't it? So now what?
Subtract 20.
Subtract 20. So KL is 30. Do we have any? Oh, 30 what? Meters. So we used our formula in just a little bit different way, right? As long as we have 2 of those segments, can we find the other one? Yes. Any questions?
No.
That's all I got for you.
Yeah, what time is it?
36.